All right, so we're going to be working on the more challenging example for average atomic mass, Unit 2, Atomic Theory, and this is on page 9 of our packet. The challenging example says the atomic weight of gallium is 69.72 AMU. The masses of naturally occurring isotopes are 68.92 for gallium-69 and 70.92 for gallium-71. So what I have done is I've put them into this, our average atomic mass equation, and the only thing we don't have, we're not solving for average atomic mass, they gave us that. What we're trying to solve for are the abundances. So as you can see here, we have two unknowns, and algebraically speaking, we cannot solve an equation with two unknowns. We need two equations to solve for two unknowns. So we need to look at the relationship between the two percents, the two abundances. And what we know is that gallium-69, the abundance, plus gallium-71, the abundance, and again these are percents, they have to equal 100%, right? And so now we've got two equations that are related, and if I solve for, let's say, gallium-69, so gallium-69 is equal to 100 minus gallium-71, I can then substitute this back up into the original equation, and then we can solve for that one unknown. So that is what we're going to be doing. So again, we're going to substitute it in. So I have 68.92 times 100 minus gallium-71 plus 70.92 times gallium-71 equals 69.72, and this is all divided by 100. Well, first thing we need to do is go ahead and get the 100 out of the way. So to get it out from being divided, let's multiply both sides by 100. So that goes away. So we've got 68.92 times 100 gallium-71 plus 70.92 times gallium-71 equals 6,972. Okay. So now that we have the 100 out of the way, now what we can do is we can combine our like terms. Or no, we're going to distribute, sorry. So we're going to distribute. So this is going to go there, and this is going to go there. So we've got 68.92 times 100, sorry. 68.92 is 6,892 minus 68.92 times gallium-71 plus 70.92 gallium-71 equals 6,972. Got a little messy there. All right, moving on. So now we are going to combine these like terms. So we've got 6892 plus 2 times gallium-71 equals 6,972. All right, so now we're going to get our 2 times gallium-71 on the same side. So I'm going to subtract 6892 from both sides. That goes away. So I have 2 times gallium-71 equals 80. All right, we're almost there. Well, I'm going to divide both sides by 2. So that goes away. So now I've got gallium-71 equals 40. And that is 40%. Now we don't have to do this all over again, but what we know is if gallium-69 plus gallium-71 have to equal 100, I could put this in for here, and if this is 40, then gallium-69 must equal 60.